In this video, we're going to do some practice problems with multiple alleles focusing on blood types. So let's go into our first practice problem over here. A man has blood type O. What are the possible genotypes? So if you're blood type O, you can see this is a chart you do need to memorize. O is the recessive allele. So you need two recessives in order to be blood type O. So you're little I, little I. A man has blood type A. What are the possible genotypes? So if you look at blood type A, there's two possibilities. You could be heterozygous or you could be homozygous for A. And you need to memorize that. So you have the IA allele, like this, two of them if you're homozygous. Or if you're heterozygous, IA, little I. A woman has blood type AB. What are the possible genotypes? Remember, A and B are codominant. So you can only be IA, IB. If we're type B, you could be heterozygous or homozygous type B. So if you're homozygous, you're IB, IB. If you're heterozygous, you're IB, I. So that's your first type of problem that you need to know how to do. You need to know those genotypes in order to do the problems that will be coming up. So let's do our first problem here. A woman with blood type AB is crossed with a man with blood type O. What are the possible blood types that their children can have? So first, let's write the genotypes of the people that are mating here. So we have IA, IB for the AB individual. And then for the blood type O is simply little I, little I. And what we're going to do is we're going to make a Punnett square. So we're going to draw a square like this. On top, we'll put the gametes of one parent. So little I can make little I and little I. And IA, IB can make IA and IB. And we can put them in the Punnett square. So we have IA, IA, IB, and then little I, little I. So the possible blood types of children can have, well, we have definitely type A. Type A comes from the IAIs, there and there. We have type B, comes from the IBI there. Oh, and I made a mistake over here. I accidentally put II, and if you noticed and you were screaming, well, no, don't do that. Good, good. This should be IBI as well. So simply type A and type B is all you could make. And it looks like it's 50-50, 50% type A, 50% type B. So if we're doing some, let's just say genotypic ratios, we have 2 IAIs to 2 IBIs. So you could simply reduce that to 1 IAI for every 1 IBI. You could also, if you want to say this is a phenotypic ratio, you could say 1 type A for every 1 type B. You could also do percentages, for example, 50% type A and 50% type B, right? So all the same rules in monohybrid crosses still apply. It's just now we're dealing with a few more phenotypes and more genotypes because we have multiple alleles rather than 2. Okay, so there's nothing too difficult or too different. Let's do another problem here. A woman with blood type A has a child with a man with blood type B. Is it possible for their child to have O blood type? Explain and support your answer with a Punnett square. So when you're doing these problems, I want you to try to pause the video and try it yourself. So you should have paused this and you should unpause it after you're done. And so remember that type A can be a variety of things. Type A could be IA, or IA, And type B could be IB, or IB, And so our question is, if you have a type A person mating with a type B person, could they make type O? And so really they could, but it really depends, right? If you look carefully, if they're homozygous for these, they can't make type O because they don't even have little I to donate, right? If one of them is heterozygous and the other is homozygous, it still won't work because both parents have to give a little I, right? Because you have to have little I, little I. So it still won't work. So the only way for this to happen is if both parents are heterozygous for blood type A and B, because then they both have little I to donate when they're doing the fertilization event to make a type O. And so you can support your answer there with a Punnett square. We have IAI over here. You have IBI over here. And so you'll notice you could make an IAIB. You can make an AB blood type. You can make a B blood type. You can make an A blood type. And you can also make an O blood type. So about 25% chance, 25% chance of O if your parents are IAI and IBI. If they're anything else, if they're not homozygous, if they're homozygous, then they're not going to make that. Or if there's homozygous with a heterozygous, they still won't make the O because they need both to donate an I in order to make the O child. So it requires a bit of thinking. So think about what your genotypes are first, and then think about what the genotype of the target is. Blood type O, right? I should have written that out first. We want O, which is II. That's your goal. Can your genotypes of your parents that you have there make your goal? And they can only if they both have a little I. Let's go to the next problem. What are the possible genotypes of the parents of a boy who has blood type AB? Support your answer with a Punnett square. So this is really good. And I want you to think about this, pause it, and try it out. So we know that the boy is type AB. So we'll write that out. In other words, the boy is IA, IB. So what that means is one parent gave an A and one parent gave a B. So we can already take some things out of the picture. We know for sure the parent cannot be little I, because one had to give IA, one had to give IB. So I know that one possibility is probably IA, little I, for one parent. The other parent could have been IB, little I. This works, right? Because you can get IA here, IB there. Okay. You could have also had IA, little I, and IB. That's a possibility as well. Because you have IA from this parent, IB from this parent. You could have had IA, little I crossed with IA, IB. Because IA from this parent, IB from that parent. Right? And you can basically do the same process again, but this time you can assume one of the parents instead was, like, you can go the other way around. Like, you can have, I think this is all the combinations. Yeah, we have IBI, IBIB, IA. Oh, one more. You could also, if you think about it, have an IAIB with an IAIB. Because this has an A and that has a B, and they can donate that, or the other way around. It doesn't really matter. But they can all contribute that to make the child AB. So those are the different combinations you can have. So really, I think the only one that you can't have in that combination is little I, because this parent just does not have a B or an A to contribute. I think I got all of them. If I missed some, let me know, and we'll add that to the video. But again, you can now support your answer with a Punnett square. So I'm not going to do all of these, but just to show you, if I had IA crossed with an AB typed with an AB parent, so let's do this so we can IA, IB, and now we have IA, IA, IB, IA, IB, IB, IB. So you can see that we can produce a type AB child here. So you can support your answers using Punnett squares like that. All right, let's try our next problem here. This will be our last problem for this video, and then actually we'll do the last two problems in this video. So we have, in humans, blood type AB is codominant, a codominant trait. Suppose Jim has blood type AB. So let's write Jim out here. Jim has IAIB. And his wife, Rebecca, has blood type O, little I, little I. What are the possible genotypes and ABO blood types of their children? So we're simply going to make a Punnett square. So we'll do IA, IB from Jim. That's a sperm you can make. Rebecca can make little I, little I. And we're going to do the fertilization, IAI, IAI, IBI, and IBI. So what are the possible genotypes? Well, we have a 1-to-1 IA, I, it's an I there, to 1 IBI. And that basically means we have a 1 type A to 1 type B ratio. So we have type A and type B blood. That's possible from a cross between IA, IB, and little I, little I. So let's try this next one here. This one's a bit of a thinker, so pause it. Suppose a father of blood type B and a mother of blood type O have a child with blood type O. What are the chances that their next child will be blood type O, type A, type B, type AB? So we need to make a Punnett square. Now, a lot of you, if you pause this, might have been stuck on this blood type B. You might have said it depends. It depends if this is homozygous or heterozygous. But if you think about it, we told you that. They had a child who's blood type O. The only way for this parent to make blood type O with this parent here is if this parent has little I as well to donate, because this is little I, so both parents must have that. So we know this parent is IBI crossed with little I, little I. So we'll do that Punnett square, IBI, little I, and we'll get IBI, IBI, little I, little I, little I, little I. And so we can see that for type B, we have a 50% chance. For type O, we also have a 50% chance. But for type A, 0%, not possible. For type AB, 0%, also not possible. So sometimes we don't directly give you the genotype, but you have to kind of read some information to infer the genotype from that information there. And if you know how fertilization works, then you're in the right track. In the next video, we're going to take a look at something called the rhesus factor for blood types and do a few problems with that. And then we'll finish up by taking a look at how blood donations work in when you donate blood, if you know your blood type.